For completeness, let's do the table of contents. Chapter 0, Prerequisites. 0.1, Elementary Number Theory. 2, Set Theory. 3, Linear Algebra. Chapter 1 is Group Fundamentals. 1.1 is Groups and Subgroups. 2, Permutation Groups. 3, cosets, normals, subgroups, and homomorphisms. 4, the isomorphism theorems. 5, direct products. Chapter 2, ring fundamentals. 2.1, basic definitions and properties. 2, ideals, homomorphisms, and quotient rings. 3, the isomorphism theorems for rings. 4, maximal and prime ideals. 5, polynomial rings. 6, unique factorization. 7, principal ideal domains and Euclidean domains. 8, rings of fractions. 9, irreducible polynomials. Chapter 3, field fundamentals. 3.1, field extensions. 2, splitting fields. 3, algebraic closures. 4, separability. 5, normal extensions. Chapter 4, module fundamentals. 4.1, modules and algebras. 2, the isomorphism theorems for modules. 3, direct sums and free modules. 4, homomorphisms and matrices. 5, Smith normal form. 6, fundamental structure theorems. 7, exact sequences and diagram chasing. Chapter 5, some basic techniques of group theory. 5.1, groups acting on sets. 2, the orbit stabilizer theorem. 3, applications to combinatorics. 4, the Sylow theorems. 5, applications of the Sylow theorems. 6, composition series. 7, solvable and nilpotent groups. 8, generators and relations. Chapter 6 is Galois theory. 6.1, fixed fields and Galois groups. 2, the fundamental theorem. 3, computing a Galois group directly. 4, finite fields. 5, cyclotomic fields. 6, the Galois group of a cubic. 7, cyclic and Kummer extensions. 8, solvability by radicals. 9, transcendental extensions. And there's an appendix to Chapter 6. Chapter 7, introducing algebraic number theory. 7.1, integral extensions. 2, quadratic extensions of the rationals. 3, norms and traces. 4, the discriminant. 5, Noetherian and Artinian modules and rings. 6, fractional ideals. 7, unique factorization of ideals in a Dedekind domain. 8, some arithmetic in Dedekind domains. 9, p-adic numbers. Chapter 8, introducing algebraic geometry. 8.1, varieties. 2, the Hilbert basis theorem. 3, the Null-Stellensatz preliminaries. 4, the Null-Stellensatz equivalent versions in proof. Localization, primary decomposition, tensor product of modules over a commutative ring. 8, general tensor products. Chapter 9, introducing non-commutative algebra. 9.1, semi-simple modules. 2, two key theorems. 3, simple and semi-simple rings. 4, further properties of simple rings, matrix rings, and endomorphisms. 5, the structure of semi-simple rings. 6, Maschke's theorem. 7, the Jacobson radical. 8, theorems of Hopkins, Levitsky, and Nakayama. Chapter 10, introducing homological algebra. 10.1, categories. 2 products and coproducts, 3 functors, 4 exact functors, 5 projective modules, 6 injective modules, 7 embedding into an injective module, 8 flat modules, 9 direct and inverse limits, and then there's an appendix to Chapter 10. Then he has a supplement. He has S1 chain complexes, S2 the snake lemma, S3 the long exact homology sequence, S4 projective and injective resolutions, S5 derived functors, S6 some properties of ext and tor, S7 base change in the tensor product, and then he has solutions to some problems. Oops.